Hi everyone, welcome to May 30th, 2023 SIG Node weekly meeting. We have a few items on the agenda, so we can get started. So first up, Sergey has shared a list of KEPs, and then we have a big list, I think 31 KEPs open. So we really need to finalize what we can really achieve during 128. So I think what we can do is maybe next week we can make a pass and create a final list. And this week we can try and go through and review and approve what we can. I mean, folks that want to drive something and we want to make sure something is in 128, make sure that you have approvers and reviewers who have the time to help you with your KEP. I know, Sergey, you have, do you want to add anything or it sounds okay to you?
No, same as you said.
Okay.
We need to make sure that if you own, make sure that you open and you rest activity and stuff like that.
All right. I think, Sergey, your video is frozen.
But I understand him.
Yep. All right. Okay, so we can move on to the next item on the agenda. So, Harshal, I know you want to talk about swap. Do you want to quickly give an update?
Yeah, sure. I'll just give the link here in the chat. So this is the enhancement we are trying to move forward the swap, and we would like to take a cautious approach here, considering the impact of swap on the cluster, especially on the node. So we are proposing uh, to enable swap only for the burstable parts. So the idea behind it is that if you allow user to set the swap values like you do in case of memory and CPU, considering how much little we know about the swap, probably we may not end up in a right situation. So our idea is to enable only to the burstable parts and calculate the values automatically, and this enhancement actually describes in detail how you can arrive at those values. And once we get enough confidence in future, maybe we put it in the same category as today we find memory and CPU. So I'd like to have people in this group take a look at that enhancement, share your opinions, and let us know if we can move forward with that.
Yeah, I think one more limitation we discussed before is whether we can limit everything to C group v2 only, because in C group v2 we have way more control, and security from security perspective, it will be much better to do it in controlled fashion rather than just enabling that whoever gets it will potentially get their secrets exposed and stuff like that.
Okay, so your suggestion is we only do this for C group v2. We can definitely add that in that cap there.
Yeah, I think it makes sense, and that will also encourage people to move to V2, as a way to get new features.
Yeah. But overall, if I'm sensing it right, we are in support of this to move ahead. And except just let me know on the cap whether do you agree with this approach of cautiously moving forward. We have split the beta into two phases, so let me know what do you think about that on the comments on the PR there.
Sergey, you'll be able to make a pass because I've seen what Harshal is.
Yeah.
Yeah. Okay. Thanks.
Thanks.
All right. Thank you. We can move on to the next topic. Peter and Marcus, discover kubelet C group driver from CRI. So I just reviewed it before the call. Peter, go ahead.
Yeah, I saw your note. So there is now an outstanding question that I could make sense to bring to the larger team. But yeah, we just wanted to illuminate that we have the KEP open, and want people to take a look at it. Independent of the open question, we decided to break up the runtime status field into Linux and Windows specific fields because the C group driver isn't really that relevant to Windows. But other than that, this changes as we discussed a couple months ago. The open question is now, do we need this generic, way for the runtime to report some information up to the kubelet, especially considering at this point, the only C group driver that C group v2 supports is systemd. And, I don't know of really any plans to add C group fs. Do we even need to do this, or do we just, begin the process of deprecating C group fs? I think that's a slightly different conversation, but in terms of the question about whether there's other things that we could use this for, I think we had kind of started to talk about, part of the initial conversation that brought this up was beginning to think about who the owner of some of these, runtime configurations would be. Right now there's some, with the C group driver specifically, there's a split brain thing going on. I can't think of any specific fields that we currently have that should be moved over, because this one's kind of the only one where the kubelet and the CRI need to be in sync. But I know that there was thought about maybe leveraging this for QoS classes, to have CRI be able to illuminate, broadcast which QoS classes exist so that the kubelet can inform the scheduler about it.
And Peter, one more thing is what we can also automatically discover configured runtime class handlers.
Right. Totally. That's a good point.
Should this be a separate call? Are we overloading the runtime status? So that's one thing. Should it be get runtime features as a separate call? That's one thing. And one more thing I wanted to add is when we were discussing user namespaces with auth, the question came up, is there a security issue? The runtimes are supposed to fail if they are not able to create a user namespace, right? Now, do we think we need something like this where when the kubelet is calling into the runtime, it gets a list of supported features? Or say a runtime is too old, it doesn't even know about user namespaces and it's not failing, and it gets some pod configuration that says I started it correctly. So do we want this additional runtime check to see kubelet gets a list of features, and if user namespaces is not in the list, it'll not even try to start a pod or fail it? I'm not sure if that makes sense or not.
Yeah, I think having a separate call is fine with me. I think we just stuck it in here because it's, this was a place where the kubelet was asking the CRI, hey, what do you have for me in terms of readiness status? But I think, a separate one makes sense. But figuring out what the kind of communication method would be, what the schema would be, might be a little bit tough, because the user namespace is more of do you support user namespace? Whereas the C group driver is which C group driver are you choosing? But I think that generally having a way for the kubelet to ask the CRI for information and having that be all wrapped up into one, I think that makes sense.
Yeah, go ahead, Derek.
Yeah, I think I would avoid, I don't disagree with what you're saying, Mernal. I just think if we keep this kept just focused on the minimizing misconfiguration issues between runtime and kubelet, I think that just language in this kept saying if the runtime reports something, the kubelet will then steer to that rather than its config. I think that that's fine. I think to do the broader issues, there's still things obviously that kubelet is setting up that runtimes are not setting up, and whether that's which C groups are actually present on the system. All that gets into a bigger can of worms. Like someone was asking me this morning about PIDs and their enforcement, and that's still just a kubelet-oriented feature. So anyway, personally, I would just keep this at the discoverability thing and not necessarily feel like we need to solve all the problems right now.
Yeah, I think that makes sense, Derek. Yeah, we just start with this and see if it makes sense to expand.
So I do like the idea. Oh, someone else, go ahead.
Sorry, I forgot where to raise the hand. So cut 9. And so my question is, shouldn't we create of the runtime class is to serve this purpose? The original runtime class is actually to answer this kind of the question.
So Don, I think in this case, though, the question is, what is the preferred C group management model of the host node wide, whereas the runtime class is pod specific. And then I don't think we can actually have different managers of the unified C group hierarchy. So this is basically just saying, who is that manager? Correct me if I'm wrong, Peter, right?
Yeah, we're not trying to extend, like Containerd has the option to have C group drivers per runtime class, but we couldn't really think of a reason to integrate that. So we're not including that. So I think the runtime classes were brought up because that is an option for the CRI to tell the kubelet, this is what this is what I have for you. Like, this is what I'm supporting. Go ahead and, instead of having, to have the CRI configuration saying, here's all the runtime handlers I have, and then have the kubelet, have those be API objects created in Kube API and have those need to agree. It would come from the bottom up, I think, was the motivation of mentioning that. Similar to the QoS classes, where the information is going to bubble up from the CRI. CRI is the one that owns it and bubbles it up to the kubelet, which will then tell the scheduler and everyone, like, here's the state of this node. I agree with you, Derek, that we should keep the scope of this kept to be just like have CRI tell kubelet what C group driver to use. I also think that it is relevant to discuss, like, the general pattern of CRI to pass up information to the kubelet and make sure that we have the API extensible in such a way where we could support these other options, because I agree that as we go forward, I think that there will be other situations where we want to extend this to be like CRI will be telling the kubelet much more in the future. So I think a separate CRI call makes sense to do this, so that the kubelet can ask it at different times than it asks the runtime status. And that will give us more flexibility. But for this KEP, we're just going to add this stuff, and then we can think about adding other stuff later or in a parallel KEP.
Yeah, I agree that we should. Well, it's a good discussion that should we have a separate call, or what is the kind of extensible method in the future to add more information from the runtime to propagate to kubelets. I agree on that.
All right, so I think we have a plan. Thanks for the discussion, folks. Move on to the next item. Memo will change pod face when containers exit with 0. This looks like a new issue that was just opened yesterday. Is anyone on the call that can speak to this one?
Yes, so it's raised by me. It was discovered while cherry picking fix for adding disruption targets to critical pods. And while testing, we realized that the phase is changed between 126 and 127. In this, it seems like a corner case scenario, but I want to discuss because I think this wasn't discussed or realized during the review, and it's like side effect of the PR that is mentioned there. So the PR was to ensure that terminal face is assigned to all pods, but the focus was on deleted pods. But as a side effect, in a couple of scenarios, the face is now different than it was when the all containers exit with exit code 0 and the restart policy is always. So in a couple of scenarios that I listed in the table, it was failed, but now it succeeded. So first of all, I would like to discuss, like, is it like a bug you would consider? Or maybe it's a feature, it's a good change, I don't know. If it's a bug, like, we need to prioritize it probably. But if it's not a bug, then we should probably clean up the code now, because these components, they like in the code, they set the face to fail, but it's ignored because the face is now computed just basically from the container exit codes. So it's misleading. Any views on that?
I don't have anything off the top. Has anyone else looked at it closer to be able to give guidance, or we want to take it asynchronous and folks can review and chime in there?
Definitely is the behavior changes, semantic changes. We need could be cause some problem for customer, for user. Okay, so semantically is correct or not, we can decide it and we can discuss. But definitely it is the behavior semantic change for. Yeah.
Yes, I looked at the code life cycle, the user-facing documentation, but I don't think it's like spec there. Like, how should it be? So I think I couldn't find like resources that would say explicitly what's expected.
So the impact, it is more like those controller people using, right? So all those kind of controller, how they are consume that face. So basically, right now it is, if it's not binary itself terminated, triggered by eviction or preemption, whatever. So the face is succeed, and then associated with some reason, which is good thing. But the problem it is we just don't know existing controller, how they are, people and also customer implement their controller, how they are going to consume those kind of things. That's kind of the semantic change for user. I'm not saying this is wrong or right. I just say this is the how the ecosystem consume these things. Yeah, might cause some production issues, which I don't know. It's just based on the semantic we change this. Yeah.
Yeah, that was my question initially. Like, so if you have a job that creates a pod and it gets evicted, is the job successful because the pod was successful and it doesn't retry?
No, the job controller would still consider such pods as failed. Yeah. So the disruption target was actually designed to help with that, but actually this might be even yeah. So here it's interesting. I didn't think about this, but if the face is succeeded, the job controller would not attempt to match the disruption target condition, and thus you may not be able to match match the text pod with the pod failure policy. So this might be something to look at. Although probably it's like rare for users to use jobs that would, when SIG termed, they would exit with 0 exit codes. Like this is sort of asking for troubles anyway, but yeah, it might be an issue. I'm not sure if this answers your question. So if, yeah, the pod, but yes. So when you say evicted, it's eviction like due to node pressure, for example, yes? Not deletion.
Yeah, like a no pressure eviction. So I think in your chart that shows as success now.
Yes, but the tricky part in job controller is that job controller. No, wait. Job controller will consider this as succeeded, so the job will be succeeded. So I went. What about the different scenario? Yes, in this case, the controller will just consider the spot as failed, and the entire job will succeed. Which is probably okay. I mean, if you handle SIG term so that you exit with 0 in the pod, then probably you did like checkpointing or something. That, like, in my view, if you end with 0, handle SIG term and exit with 0, it means that you control the file left, sort of, or the exit of the pod.
But there's I think it should be okay if we can handle other controller right now, because anyway, controller upgrade first, then node upgrade. So controller should, if we can change controller, have this forward compatibility, then should be okay.
Yeah. So job controller, I think is fine, but yeah, in the wild, in production, customers may have different.
Yeah. Definitely, there's some customer controller. But I think that at least the out of box Kubernetes controller, if we could scan through all those kind of controller and figure out how the handle, that will be good, right? So at least that's the minimum requirement. Otherwise, this is kind of like the the regression issue for the users.
Okay, so I'm reading this as it's not like an issue per se, and we can stay with the behavior. I will yet try to consult this with Clayton, who participated in the PR, and yeah, I also asked him. And if so, then I think we just clean up the code, right, for the different subcomponents of kubelet to do not set the phase to fail, because that's misleading, right?
Right. Thanks. Yeah. You can continue on the issue over there.
Okay, so please, if you have some further thoughts, comment on the issue, and otherwise, I'm reading this as it's fine.
Right. So next on the agenda, we have the bpfd presentation. Andrew?
Yep, I'll try to be short. Can you give me access to screen sharing, please?
Yeah, just a sec. Sorry, are you able to give him host? It's not showing up for me for some reason.
Let me try. Do not know.
Oh, yeah, I got it now.
Great.
Awesome. Okay, can everyone see my screen all right? Cool. Okay, let me just give a quick intro. My name is Andrew Stoikis. I work mostly in SIG network in the Network Policy API subgroup, but more recently as part of my company's kind of endeavors, we've been working, well, I work for Red Hat in the Office of Emerging Tech, and we've been working on a new project called bpfd. I poked in my head last week just to see if y'all would be interested, and I didn't get any no's. So I'm here to do a quick presentation. I'm gonna try to keep it pretty short. I'm not gonna do a live demo just in concerns of time, because I know we have a lot on the agenda, but still feel free to raise your hand during the presentation, and I can stop and try to answer any questions. Okay, so I'm not going to dive deep into what eBPF as a technology is. I think many of us have heard that buzzword because it's been used as a marketing technique by many companies. People are really excited about it, and it's kind of this new general purpose framework that allows users to, I won't say easily, but allows users to run sandbox programs in the kernel without having to change kernel code. It can be used for a ton of different purposes. I come from a networking background. That's kind of where it started, but now it's been expanded to include use cases for monitoring, tracing, and security. And so because of this, we aren't just presenting our work to like SIG Network or SIG Node or SIG Security. We're trying to go for all three because we think BPF and Kubernetes kind of has a lot of overlapping uses, and it can affect the security of a cluster at large. So all three SIGs are kind of important. So eBPF and Kubernetes itself has been like majorly on the rise. Obviously, if you've been to the past couple of KubeCons, it's come up more and more, Cilium being one of the big drivers of that. There's a bunch of other examples as well. Apart from the Cilium and Calico CNIs, you have Pixie, which is around observability, KubeArmor, which is runtime enforcement, Blix, which is from Kong and being donated to Kubernetes SIGs, which is going to be a gateway API L4 conformance implementation, another project I'm working on along with Shane from SIG Network. And then we also have another example of NetObserve, which is a open source observability operator. They all kind of rely on eBPF as their underlying technology. So although, you know, the proliferance of BPF and Kubernetes is great, it leads to a lot of kind of interesting problems. One of the main ones is that BPF today always requires privileged pods, specifically, and it needs cat BPF to load and manipulate BPF programs and BPF maps. That's at the very minimum. Most often in real deployments, you need even more. As we can see, I did a sample of the NetObserve operator, and we need all of these caps listed below. Another big problem with running BPF and Kubernetes is there's no cooperation means right now. So if one operator tries to load a program on the same hook as another operator, things can get messy. Things can get undeterministic. There was actually a really good talk at the last KubeCon, which I'll need to link here, from Datadog and Cilium on an explicit case of this happening. And it was almost impossible for them to figure it out. Like a whole KubeCon talk dedicated to figuring out what was broken and what was going on. So this is obviously one of the biggest problems. It's also really hard today to debug these problems, like I just mentioned. And then additionally, like there's a ton of duplicated code and functionality across applications which want to deploy BPF and Kubernetes. So these are kind of the main challenges we see from a BPFD community, and it's also some of the main challenges we've set out to solve with BPFD. So let's hop into what it actually is. Obviously, it's an open source project. It started in Red Hat's Emerging Tech networking group, and it actually started in the Red Hat ET GitHub organization, but has now been moved to an unopinionated BPFD/dev organization. So fully open source project. We are also listed on the ebpf.io projects page. And what it essentially is a system daemon for managing BPF programs. This means that we're managing full lifecycle BPF programs, loading, unloading, and we're providing a privilege separation so that only our daemon is privileged while our users don't have to be, which is kind of really important for one of those, for a lot of security use cases. For XDP and TC programs, which are both network-oriented programs, we leverage the libxdp protocol in order to allow program cooperation. So that Slam and Datadog program stomping problem we saw in last KubeCon, we're aiming to try and fix that. And today we're using libxdp protocol to do so, which we have a link to that in our links page. But in the future, this functionality will one day be actually built into the kernel. And when that happens, we'll kind of use that implementation instead. And we're also going to be providing a lot of policy, security, and visibility tools around loading BPF. So we'll give fine-grained control over what users can load BPF, what hook points they can load to, and we'll also give a lot of visibility into what BPF programs are loaded onto a system, and if any are malicious based on our analysis. So some details: bpfd is developed in Rust. It's built on top of a Rust BPF library called Aya. And one of our main use cases is focused on deploying BPF in Kubernetes, which is why I'm here. So we also have a Kubernetes operator, which is all written in Go. So we're not asking anyone to learn Rust, but it has its perks for being a system daemon language. And today, people who are already writing their eBPF enabled applications for Kubernetes using existing libraries such as Cilium, Aya, libbpf, et cetera, they can still use those, but they can then load and unload programs via bpfd. So next I'm going to show two slides that just are kind of images. I really love images. The first one is showing like what BPF deployment and Kubernetes specifically looks like today. As I said, we have a few of our BPF enabled applications on the bottom. This is on a single node. They're all deploying daemon sets in order to load their BPF applications. These daemon sets are all privileged. They all require cat BPF, and they all use kind of their own stack, whether it's libbpf enabled, Cilium eBPF enabled, or Aya enabled, to load and manage their BPF programs. So as you can see, there's a lot of room here for duplicate functionality. There's not really any segmentation of capabilities. Every application today has to do this. And we don't think this is the way things should be done. In the future, we're hoping for it to look something more like this, right? So now your BPF enabled applications fit in their own layer and they do not need cat BPF because they aren't the ones actually loading the BPF programs. Instead, they simply create their program specific CRD object, whether it's XDP program CRD, TC program CRD, or tracepoint program CRD. And bpfd, which is the privileged entity in the system, will load their program and manage all their map pinpoints. Then what the applications do is use their existing Mac management library in order to interact with those programs on the host. So the overhead to kind of integrating with bpfd stays somewhat small, but we still get the observability and security benefits of using kind of a centralized daemon. And it also allows other Kubernetes users to dynamically deploy BPF programs to the cluster. So if you could have some core infrastructure operators in your distro that need to use BPF, they could also use bpfd, but then if you wanted to open up the ability for customers to do so as well, you could, which is kind of a cool feature. So we're all here for Kubernetes, right? And so I think one of our biggest focuses in the bpfd community is how we make this work on Kubernetes and the value add we bring to Kubernetes. So part of that was writing an operator. I already mentioned before, it's written in Go using operator SDK. Many of you folks are really familiar with it. You can really easily test it from our project today, which is a simple make target, make run unkind. It includes a couple Kubernetes APIs. The first one being, this is actually stale because we just changed our API. We have dedicated program types instead of BPF program configs. So TC program, XDP program, and tracepoint programs are the types supported today. We're also hoping to expand to uprobe and a few others in the near future. In addition to that, we have a BPF program CRD. So this is used to store per node metadata, and it's also going to soon be used to enhance the observability of a cluster. bpfd will be able to report back to admins all of the BPF programs that are loaded on their cluster, not just the ones that we loaded with bpfd, but everything that's running on your system. So an admin will be able to go, okay, show me all the BPF programs that are running on my cluster that aren't controlled by bpfd. And what are they doing, right? What are they? You can't do that very easily today. The last thing we include is a config map. Instead of having a dedicated CRD for configure an operator, we are just using a config map because there's not many things to configure. The last really cool thing to note here is our BPF bytecode image spec. We've written this in order to solve the problem of distributing BPF bytecode. Today, the way it works is bytecode is often embedded into the binary of the user space application that's loading it. So therefore, in order to release a new BPF program version, you have to release a new user space version too. What we've done is package BPF programs into bytecode. So now you can have fine-grained versioning control over your BPF program, and you get all of the benefits of a standard OCI container image, such as signing. So that's really cool, and it allows us to kind of integrate with Kubernetes a lot easier. Okay, so I am not going to actually do this demo in front of you because it's going to take some time. I'll just talk through it really quickly, and on the slides are explicit instructions for doing so. Pretty easy. All you need is kind, so you can give it a try. But what this demo shows is 2 XGP programs being attached to the same interface on every node in your cluster. One is clobbering the other at first, and then you change the priorities, and now it's no longer clobbering. So it's a very simple demo. And we show clobbering versus not clobbering by just counting packets. So this is kind of a deeper image into that demo. So please go check it out if you want. It's a lot easier to run now. We just got done with our 0.2.0 release, so everything will stay working. Great. So I just kind of give you all a really fast overview, 10 minutes, trying to not take all y'all's time of BPF and bpfd. What we're more interested in and why we're here is trying to figure out what this looks like for Kubernetes, obviously. We brought this up to SIG Network already around where should we continue the discussion. And out of that, we've actually created a new Slack channel for bpfd and a Slack channel for eBPF in general in Kubernetes. So you can find us in either places. We're also trying to figure out what role do the SIGs, network node security, want to play here. Right, like obviously SIG Node would care about this technology because a user could really easily break a cluster, right? I mean, you could tear everything apart with BPF today super easily, and that includes kubelet and everything around it, right? So we really want to have multiple SIGs involved, and we're trying to figure out if that needs to be in a dedicated working group under a certain SIG or its own SIG. Probably not, but just ideas we're throwing around. And then the last question we want to ask is like, could we see some of these APIs being endorsed by multiple SIGs? Meaning maybe everyone doesn't want to use bpfd, but we all agree here that, you know, having APIs to control BPF in a Kubernetes cluster is smart. So why don't we put those in upstream and let various implementations flourish? Yeah, and then the last thing, short roadmap for bpfd. You can see a bunch of stuff we've gotten done. Super excited about that. You can also see our tracking project for more. We have a bunch of cool features in the pipe around observability and some other cool stuff like being able to attach XDP and TC programs to interfaces based on pod labels. So if you want to attach a TC program to all pods with label X, you can do so. So yeah, I just want to open the floor up for any questions. The last slide is just links. Thanks so much for your time today. And yeah, you can find us if we don't get to answer all our questions in Kubernetes Slack at bpfd or hashtag eBPF. So thanks so much for your time today.
Thanks, Andrew.
Yeah, I have a small question, follow-up question on that. Like you said that SIG Node will care about it because of security and reliability. I also curious how many problems do you experience with attributing eBPF with specific pods and processes? I know Pixie had a lot of, like, I've been talking to them and they had a lot of problems with attributing specific pod to signals they receive from eBPF. And
I don't really follow your attribution for a specific pod. Can you elaborate on that a bit more?
So if you receive eBPF events on a kernel level, you don't necessarily know which pod this belongs to. Like you know, like some event about the process, but you don't know which annotations, so like image this process is built on, like from
Right.
a perspective. Do you like, and I understand that many providers may want this information and they all will need to hook up in some eBPF process start events or something like that. So do you experience any problems with that? Like, do you provide any solutions?
I don't think we provide any solutions for that use case yet, but this is why we came to y'all. Like, that sounds like a really great first use case. If you could even just jot a note down under my agenda topic, I'm happy to make an issue and kind of see what we can do in the future.
Okay, thank you.
Yeah,
Okay,
for sure.
in one of our projects, we were doing the same thing by inspecting from eBPF program where C group passed for the process. It's not really trivial, but it's doable.
Yeah, the problem with many vendors will do the same simultaneously, they will have a problem because they
Right.
for the same events.
Yeah, if we can deduplicate effort around, you know, even tracing, logging, and debugability of BPF programs, like that's kind of what we want to do, especially in our operator. And we can do that because bpfd can provide any node specific level metadata that we would need, hopefully, to be able to report that back to the user. So
I think another one is, Andrew, how do we know what process loaded a particular BPF program? Like if a rogue process came and loaded something and went away. So maybe we will need that kind of tracing as well.
cool. Yeah,
If a hook was inserted, that is kind of, you know, snooping on data on the node.
Yep. And I think this brings up some good stuff. I think the next time I come back here, or someone from my community comes back here, if we can give you all a presentation on like a distinct short observability tool or use case we've done, that would be really cool. If we can show like what you're saying, a BPF program loaded on a node, it's loaded by a process we don't recognize, like here, we're giving that information back to the user.
Yeah, or a warning. Okay, this is not something that was loaded through bpfd. You may want to check it out.
Yep, 100%. Cool. So then I really appreciate y'all's time. We are having a generic eBPF meeting for Kubernetes coming up on June 5th. You can go on our channel and find out more. And we have a weekly bpfd meeting every week. There's more information in our GitHub and our website. Please reach out with questions. I'll keep in contact here. Like, we want use cases coming from SIG Node, and we want to see how we can make this better. So really excited about it. Thank you.
Thank you. Right. So the next item on the agenda is CRI pull image with progress.
Yes, that's mine. Hello. I'm just bringing this up again. This was started last year. Unfortunately, I lost time to work on this since then. Now I'm back in the game, so sort of. So I did a bit of a proof of concept for the Kubernetes implementation, how it will be used. So for those who missed it or maybe don't remember because it was so far ago, briefly, this is about extending the CRI to support not just pull image request, but also pull image with the progress, so that the runtime will send back the information every now and then about at what stage the image pulling is at the moment. And the request is supposed to be parameterized, and the runtime is supposed to act upon the parameters. For example, the image can be requested to be pulled with a progress reported every 1 gigabyte or every 30 seconds, or maybe every 5 minutes, or maybe every 25% of it being downloaded and then backed. And the background is that in HPC AI, some of the container images, they are huge, like 20 gigabytes. It can be image size. And if the network bandwidth is not allowing to download such an image in 5 seconds, then the owner of the workload that's been deployed might be just sitting and wondering what's going on. Is the image available, or should I wait for 5 minutes until the runtime just fails with the timeout, not being able to reach the registry? And for that purpose, it's nice to have the events published on the pod object when the image is being pulled, just so that the owner of the workload knows that something is going on, and then we can judge approximately how much time left.
So I think thanks, Alex. I think that in general sounds useful, but I want to make sure if we are also covering something that Docker shim used to have. So with Docker shim, right, if an image is taking too long, then the kubelet was able to talk with Docker and give it more time to pull the image. Right now with CRI, if we have a very big image, we could be timing out, and we could like it could result in trying to pull the image again. So are we also trying to bring back that old behavior where we say, oh, as long as the image pull is making progress, we give it more time, because it will be very expensive to start from scratch again, and there's no guarantee that the pull will succeed again within the same time.
That's a good question. I will have to study that. I don't know.
Okay, yeah,
So,
no worries. I mean, since you're
yeah,
touching this code, I would rather
Yeah.
that we address that as well.
of course,
with
of course.
with the progress timeout is probably the best for now. Just if you haven't had progress for the for
Exactly.
some,
Yeah.
that's-
Right.
that's
If you don't see progress for a minute or two, then you can cancel it. Otherwise, if it's going, let it continue.
Yeah, of course.
Something like that.
we actually support that with a configuration already for now. So adding it to the API would be nice.
Yeah, I mean, but we still respect the CRI timeout in the kubelet, right? So if kubelet will have to be aware of whatever the runtime is supporting to allow extending it.
Yeah. Back to the discussion earlier. How do you find out what that timeout is configured to? It'd be better for them to give it to us.
Right. Anyhow, so to review the CRI proposed change, I think the comments last time were that it would be nice to see the sketch of design of how it will be used in the Kubernetes. So now that's there. I didn't find anything obvious that would be wrong with it, but I will now consider what Mrunal just mentioned, of course. And otherwise, it's open again for the comments.
Yeah, the hardest part is when you're requesting percent. The reason that's so hard, we don't know what the ultimate size is going to be on the image pool.
Yeah.
Until we're finished. So calculating percent is the hardest, but throughput is doable. That's for sure.
Do you think it's worth getting rid of it straight away at this moment if the percentage is hard to calculate? Should we just not consider it?
I think so. It just with the current distribution spec API, we really don't know what the size is going to be.
Okay, so time-based or just processor sized?
And time is the problem with the large ones, right? It's more of a timeout with progress. So if you haven't had, a megabyte over the last 10 seconds, that's easy to do. But if you say timeout, if you're not finished within 5 minutes, that's good for small images, but horrible for 20 gigabyte images.
Yes. Well, it can be probably both timeout on no progress and reporting the progress so that the user can see that something is going on, not just we did not reach a timeout.
I haven't read your CAP, but the other thing that can happen is you can be trying to pull the same image for multiple containers or multiple pods. And we do cache that up so that only one's pulling at a time, but the others are waiting. So again, that timeout in progress needs to be tied to the original. Just a heads up.
Yeah, but this is based on the existing pull image request. So whatever way was working until now, it's the same, but just was transmitting the progress backwards to the kubelet or the CLI to whoever requested the image.
I mean, Mike, maybe you can add some comments on the CAP, and
I'll do that.
take it from there. Thanks.
Yeah, this is not for discussion just now. I'm just bringing this up that we're trying to, or I'm trying to make this into the current release. So
we'll chat. Thanks.
Yeah, okay. I think this is important. I mean, it'll be great if we can make progress on this one. Yeah.
So let's include this in the 1.28 candidate, because next week we are going to finalize, right? So let's make this as candidate. Okay.
Mike, can I appoint you as a reviewer, approver for this one? All right,
Yes.
thanks. Yep.
Cool. Thank you.
All right, thanks. So next one we have is PR, which is talking about disabling CPU quota for guaranteed pods. Martin, I know you are on the call. Or he's not anymore. Oh, he's on. Martin, you want to cover this one?
Well, I first want to want to hear the question, and then I can provide some info.
Oh, okay, so this is a pull request opened by you. I think it's about
Yes.
yeah. Do not set CPU quota for guaranteed pods, and it's on the agenda. So maybe you want to present it?
Okay,
Yeah,
I can discuss it.
Yeah,
so it was originally opened by Artyom, who is no longer working with me. I resurrected it and rebased it. There's still some reservations about one of the pieces. This is the smallest possible patch that would work. However, there are reservations about the CPU quota being disabled for guaranteed quality of service pods that have no CPU pinned, meaning from security perspective and resource security perspective, it's actually opening the hole just a bit too much. At least that's the reservation I'm hearing. I just added a comment to the PR. I have a private branch where I'm playing with a different approach that's slightly more secure. It's also, the patch is also a bit more invasive. Not too much. I thought it would be worse, but I basically need some guidance. Probably, I mean, we have Francesco and Swati here, but we probably want to hear from Kevin, who is not here, about which approach is preferable to him, since he's the one that needs to approve it. But we don't have him here. So the one thing we can discuss right now is I can take my private branch and basically post it to the PR, but I don't want to lose the current solution just yet. So I can open a new PR and we can compare, but that splits the discussion, and I don't want to do that either. So what should we do? What should I do with the approach here? By the way, Derek has his hands up.
Derek,
hey, Mark. I was just catching up on the PR, and I was just trying to make sure I didn't misunderstand something, or maybe you could share what the concern was. I guess I would be apprehensive on eliminating the use of CFS quota for guaranteed pods that did not have exclusive CPUs. But if the PR is restricted to pods that are already given exclusive CPUs, I actually don't understand the counter argument to keeping CFS quota. Is there some relationship there that I might be missing that others are raising that would give you a pause? Or
No. You actually described it perfectly. The current PR is removing CFS quota even when there are no pinned CPUs, no exclusive CPUs, and that's just a bit too much.
Yeah, so we definitely don't want to do that. But if the okay, that's what I make sure I understand, because I think that's too much. So would we all feel good on the sweet spot then of saying if you've been given a
no pinned only totally makes sense. I think I have a solution for that. I mean, the current APIs don't allow that. So I had to do a few changes I had to add two methods to a couple of interfaces, and now I think it's possible. I linked my private branch there. As I said, I can either put it into the PR directly, losing the current solution, or I can open a new PR. It's probably up to you to decide which one you prefer. I think if the current one is not acceptable, I think I prefer just replacing the content with the new approach.
I guess I just want to make sure I understood what the original PR author desire
exactly what
was.
you said.
Okay. Yeah. I wouldn't have any hesitation to merging a PR that eliminated CFS quota for containers that had exclusive CPUs.
Oh, the issue, there is a different. Sorry, let's put it differently. Containers are, easy. It's the sandbox. Basically, if you have a container that has exclusive CPUs, obviously you can remove CFS quota because you are going to be limited by your CPU affinity. You will never be able to run on CPUs that are not yours. But the parent C group, the parent slice, will prevent you from using them because the parent slice, the sandbox one, is actually limiting you as well. It's the parent.
Yeah, I understand. If the sum of containers in the pod were guaranteed quality of service and all used integral cores, then yes, I would be perfectly fine merging that PR to not have CFS quota restricted. If there was a guaranteed pod that did not use integral cores, then we would be in a gray zone, I guess. But if you wanted to get to that spot to be reaching like a desired outcome, I think that's perfectly fine. I don't know if other people are different.
So the current idea is to remove the sandbox CFS quota when the whole pod is a guaranteed quality of service pod, and there is a container within that has exclusive CPUs.
No, I think it has to be that all containers have been assigned exclusive CPUs, meaning the pod as a whole has a
that doesn't solve the issue. Most of your pods, well, at least most of our pods don't look like that.
Yeah, there's
then maybe we can follow up. And I was just trying to think of the simplest thing that I'd be like, yeah, that makes sense. We don't need it. If I have to think through the pod with partial case to know if the hierarchy works as expected. Yeah, maybe that's the best thing to do next.
Right. We're out of time, folks. David, did you have a quick comment to close?
I had a question about the PR, but I can follow up on the GitHub PR.
Okay. Right. So we didn't get through everything. And Sergey has a request for reviews on Sidecar, and Peter, if we can carry on your topic to next week. That's also a review request. So that's good. All right, folks. Thanks for joining. See you all next week.